Hello everyone. In the series of learning data structure, our today's topic is realloc and free. So realloc is again a library function for dynamic memory allocation. So this function is used to increase or decrease the size of the memory which we are already allocating using malloc or calloc. Malloc and calloc, that is memory allocation or contiguous allocation. These are two dynamic memory allocation functions, and when after initializing or allocating the memory using malloc or calloc, we feel like it's not sufficient, or if we feel like it's more and we want to decrease the size of memory, that time we can reallocate the size of memory. For that, realloc helps us. So syntax for reallocating the memory: you have to give a pointer variable, that is rptr here in this case. Then you have to give the cast type. So cast type will be the data type, which type of memory block you want, according to which data type, the size you want, how many bytes. Realloc is a function where this ptr is the previous pointer, the old pointer, and the size is the new size. So as I told you, this rptr is the new pointer, ptr is the old pointer which we are using at the time of allocation of memory using malloc and calloc. So here it will be more clear with the help of an example. We are taking a pointer variable with a name ptr. In this ptr, we are allocating the memory. So as I have already told in the previous lecture, if you have not gone through the malloc slides, please have a look using malloc slides. So what will happen? 10 into size of int. Now we all know that integer take 4 bytes. So 10 into 4, that means 40 bytes bigger block. And as it's a malloc we are using for dynamic memory allocation, a block with which is of 40 bytes big will be allocated. And the initial location, the first address will be pointed by this variable ptr. So this pointer variable will hold the address of the beginning block of this 40 bytes. Now we are saying this 40 bytes is not sufficient and we want more size. Then what happened? We are reallocating. So here this 40 bytes, after this 40 bytes only the new size will be given to us. So PTR, which is pointing here to the base location of this 40 bytes, size of int into 20. That means integer take 4 bytes, and now 20 into 4, that means 80 bytes. So after this 40 bytes only, there will be more 40 bytes will be allocated to this, and then the total size will get 80. And now instead of this ptr, this rptr, the another pointer variable rptr, will be pointing to the base location. So like this, our malloc and calloc, what memory they are giving, realloc will give the increment or decrement in that memory. Now, understand here, it is also allowed that instead of using a new pointer variable, that is rptr, with ptr itself you point to the new location. There is no problem in that. Just to avoid confusion, I created two different pointers. Otherwise, same. PTR can also point, and then what will happen? PTR will point, instead of just pointing the 40 bytes, it will point to entire 80 bytes. Now, next we have free. So free is again a dynamic memory deallocation function. It is also present in standard library. So whenever once our work is done, what we have to do, we have to free the memory. So memory allocation is used by malloc and calloc, and when our work is done, we have to deallocate the memory. And for this, we need a free function, because malloc and calloc itself will not deallocate the memory. Hence, we have to call a function, and that function is free function. And how you will call that function? You just have to call the function free, and as an argument, that pointer variable you have to pass, which is pointing to that particular memory block, and your work is done. So now we are going to see the programs, so it will be more clear. So let me create a program, Realloc demo. Realloc demo.c. .c is the extension. So let me start writing a program for reallocation. So first I will allocate the memory, and then I will reallocate the memory, and at the end I will free the memory as well. So here I'm including the header file #include stdio.h. Now because dynamic memory allocation we are doing, so standard library also I should include. So #include stdlib.h. Now here is my main function, and from here we will start the program. So one simple program I'm writing. Let us suppose I will ask user how many block of memory you want. So that value I will store in a variable n, and because number of blocks will be allocated, so to trace that thing, to apply the loop, I'm taking another variable with name I. Now two pointer variables I'm taking. One is p1. This is, I will use either malloc or calloc to do the dynamic memory allocation, and one more I'm taking as p2, pointer variable of same integer type. So I will reallocate the memory using p2. Now let's ask user enter how many bytes or how many blocks. So user now will insert some value. That value my system will read, and I want that value because n is of integer type, so format specifier will be %d, and I want that value to store at address of n variable. Now what we have to do, we have to do the dynamic memory allocation. So here I'm using calloc function to do dynamic memory allocation. So here, what is the syntax of calloc? You have to give the pointer variable. So p1 is the pointer variable. Casting type I have to give. My casting type is integer. Then I have to give the function name calloc. So here is function name calloc. And as I have told in the calloc lecture videos, calloc takes two arguments. One, how many block you want to give that number. So that number here present in my n variable, comma, what is the data type that you have to mention. So here I will give size of, and the data type is here I want as integer. So here what will happen after this line, size of integer is 4. So 4 and these many blocks of memory will be given to me. For example, here if this n I will enter as 3. Size of integer is how much? 4. So what will happen? 3 blocks of 4 bytes. So here continuously 3 blocks of 4 bytes means this is 4 bytes. This is 4 byte, and this is 4 byte. Like this 3 block will be given to me. So if you remember in malloc what happened, the entire block of that many bytes will be given, whereas in Calloc it works like this. All these things clearly I have explained when I have taught malloc and calloc. If these concepts are not clear, you have to go and check those lectures. So here now memory allocation will be done using this. Now we have to check whether memory allocation is actually done or not. So for that also I have told you one point to remember. If the memory allocation is done, then P1 will point to the base location. Otherwise what will happen? It will point to null value. So here using this logic, we can use the condition that if P1 is equals to null. So if P1 is equals to null, that means memory allocation is not happened. So here what we have to do, we just have to print a message here, no memory allocated. Now, if this is not the case, if memory allocation is done, that means what? We just have to see now where memory is allocated. So here, let me write printf. I'll print a message that memory allocation is done. Then only I'm entering in this block. So memory allocation is done. Addresses are on following locations. Fine. It will give me locations also. We will print the address also. That's not a big deal for us. We already know how to handle addresses. So here I have to put a semicolon here. Yeah. Now what I have to do? Here I have to now print the address. So for printing the address, anyway I have a pointer variable which is pointing to that location, correct? So here I will put a for loop because there are more than one block. That's why I am applying a loop. So continuously all the memory will come in front of me. So for I is equals to 0, I should be less than n, I plus plus. And here I will print the address. So for printing the address, you will use printf. Now address we are printing percentage d \n, and here for printing address I'm using this address operator and pointer variable name which is p1, and here with every I it will print. When I is 0, address of first element. When I is 1, address of second element. Like this it will print all the addresses. Now we have to reallocate the size. So here I'm printing a message, printf, enter new block size you want. Now it's on you. You can increase the size, decrease the size, how you want, you can do that. So here user will enter some new value. That value again I'm reading, and the value I will put inside n only. So here percentage d, and this value will go inside this n. Now again what I have to do, the new size I have to print, right? So here again I'm giving a printf new size is as follows. So new size will come when we will do the reallocation. We have not done reallocation yet. What is the syntax of reallocation? New pointer variable. So new pointer variable is p2. Now here I have to give what? Here I have to give the keyword realloc. So here is realloc, and then here I have to give previous pointer variable. Previous pointer variable name is p1. Then I have to give n into size of, and here we will give the casting type. So here I am giving integer. So what memory is already allocated, now the new memory will be allocated and p2 will point. So here printf, let's see that it is done or not. So here printf memory updation or updated memory, I should write. Now again I have to apply for loop and I just have to print. So same thing I have to do. So here I'm printing this. So accordingly, on the basis of this new n, now my program will run. So let's check the opening and the closing of loop. So this is if, this is else. Actually, this also should come inside else only. So here, this will, I will close here this else. And after all this, we will free the space. So I'm writing free. Let's run the program. Okay. So enter how many blocks you want. If I'm giving 4 blocks, so as you can see, 1993184889296. Like this, 4 bytes are given to me in the memory, if you can see here. Now it's asking me to enter new size. So instead of 4, if I want now 6 blocks, what will happen in the same size? The size will get updated. So already 4 blocks were there till 196. 196 plus 4, that is 1993200, and then 204. Like this, new size is being allocated to us. So this was the demo for realloc and free. I hope this is clear. That's it for this session. Thank you very much.